So now that we've done a summary of all the different ways of factoring, we are going to look at factoring completely. And basically all that means is that we're going to go through the chart that we made, the organizer, and check for GCF first, and then look at the number of terms to see if we can do anything else. So, and we already did a little bit of this earlier, but it is possible to be able to factor more than one way. So, let me fix the camera. Sorry, I should have done that first. All right, so I just have, let's see, I don't know. Not quite. I think I have 8 examples for us to go through, but these will all be good for you to have to double check and look over and everything else. All right, so first one. So 3x squared plus 12x minus 15. So the first thing that we do before we do anything else is we check for GCF. So if you look through right here, I see a common factor of 3. So I am going to take that out. And when I take out the GCF, that is going to leave x squared plus 4x minus 5. So what I just did right there was GCF. So that's the first type. All right. Now I'm going to look at what I have left. And this right here is a trinomial. There's 3 terms. But there is not a leading coefficient. So the second part right here, this is a trinomial, and it is just an x squared term. So there is not a leading coefficient on this one. So what we need to do here is think about, well, you could do the big X if you wanted to, but we want to think of numbers that multiply to be -5 that would add up to +4. So if you think about that for just a second, think. Hopefully that means that you come up with a +5 and a -1. And remember that we can always check by foiling. So if we FOIL these together and then distribute the 3, we'll get what we started with. So that right there is your answer. All right. Next, let's try example 2. Let's see, n to the 3rd plus 7n squared plus 5n plus 35. All right, so first thing we always do first is check for GCF. So if you scan this, I see some n's but not there, and I don't see a common factor of a number between any of those, so there is no GCF. So I'm going to move on. I count, and there are 4 terms, so that means that I need to use grouping to factor this problem. So I think I'm going to just put them in order. Put those 2 in one group and those 2 in the second group. So grouping is where we make 2 groups of 2, and then we go through GCF a few times. So between these 2 in the first group, we can take out a GCF of n squared, and that would leave n plus 7. And then if I look at this group, there's a GCF of 5, which would leave an n plus 7. Now I have an n plus 7 in both of them, so I know that n plus 7 is one of the binomials, and then the other I get from the previous GCF numbers, so n squared plus 5. And again, we can check by foiling, so if we FOIL this back together, we'll get what we start with. So that one was just grouping. All right, next up, let's try example 3. How about 24n squared minus 6? All right, so first thing we always check for is GCF. So if you look at these two, I see a GCF of 6. So I'm going to take that out. And once I remove the 6, this is going to be 4n squared minus 1. All right, so now to look what we have left, we have 2 terms. So if you look at your organizer that we worked on, when we have 2 terms, we want to check and see if it might be a difference of squares. So what we want to say is this a perfect square? Is that a perfect square? And are we subtracting? And the answer is yes. So I'm going to split up 4n squared to be a 2n and a 2n. And then, in order to get a negative 1 and also cancel the middle, I need a positive 1 and a negative 1. But don't forget that we took out the 6 from the beginning, so that needs to be part of our answer. And as usual, we can FOIL to check our answer. So this problem was GCF and a difference of squares. So that would be our solution. All right, let's try another one. Number 4. Oh, let's see. How about let's do 6m squared minus m minus 15. So first thing we always do is check for GCF. I don't see one. So we know that this isn't a GCF question. But we do have 3 terms, so it is a trinomial, and it's a trinomial with a leading coefficient. So this one is a trinomial, and I'm going to say with an ax squared. So there is a number in front of our first term. So the way we do this problem is to use the x, the big X. So we need to figure out what would multiply to be negative 90 that's going to add up to negative 1. So what can we do? We need to multiply and get negative 90, but add up to negative 1. How about that? All right, but remember we need to reduce by 6 if we can so we don't overload our FOIL problem. And we can, this one, whoops, hold on a second. This one reduces to be 3 over 2. And then this one we can reduce by 2, so that would be negative 5 over 3. So then we know that one set is 3m minus 5. So 3m minus 5 is one set. And then 2m plus 3. So 2m plus 3 is the other set. And then again, we can FOIL this together to check and make sure that we get what we started with. So there's your answer for that. All right, how about number 5? So for example 5, I'm going to say h squared plus 5h plus 14. So we start by checking for GCF, and I do not see one, so we keep going. There are 3 terms, so that would make me think this is going to be a trinomial, and it is a trinomial with just an x squared. So there's no number in front. And actually it's an h squared, but you understand what I mean. So there's no leading coefficient. So we can use the big X if you want to, or we can just think of numbers that multiply to be 14 that add up to 5. Right, it doesn't work. So if we can't factor it at all, then it's considered prime. So that just means it's a prime number, and prime numbers can't be factored. All right, let's see. How about just a few more here. Let's do 36x squared plus 36x plus 9. So again, first thing we always do is check for GCF. And all of these can be divided by 9. So I'm going to take out a 9, which would leave 4x squared plus 4x plus 1. So this one was a GCF right there. So we got that. All right, so now what we want to do is look at what's left over and count the number of terms. So here's 3 terms. So this is a trinomial, and it does have a leading coefficient. So I'm going to say this is a trinomial with the ax squared. So there is a leading coefficient. So the way we do that is with the x. All right, so we're not using 9. That one's been taken out. So we need to multiply to get 4, but add up to 4. So what numbers will multiply to be 4 and add up to be 4? That would be 2 and 2. So right now, since I'm getting the same thing twice, I know that this is one of the special ones where the answer is the same binomial squared. So at this point, you could probably stop and break it up because we need to get 4x squared and a 1. But if not, you can keep going with this method. So we divide them both by 4. And this one reduces to 1/2. This one reduces to 1/2. So that tells me that both of them are the same. So 2x plus 1 squared, which if we thought about the square root of 4x squared, that would give us 2x, and the square root of 1 is 1. But don't forget that we still need to put that 9 at the front. So the way to check again is FOIL this out, then distribute the 9, and you'll get what you started with. All right, I hope that's enough examples to get you started on factoring completely. Remember to use your organizer that we made in class, just to remind you of what to look for and then how to factor.